Dividing next one, everybody. So, Mach number and sonic boom. So, we already knows what is sonic boom. So, let us see that how you can identify this Mach number and what is the formula, and as well as discuss what is sonic boom. Okay. So now we all knows that Doppler effect. So yesterday we studied Doppler effect. Do you all remember, all of you? Yes, please. Yeah. So if you saw that Doppler effect, if you have seen that, we'll understand that whenever, suppose if you are standing on a platform, whenever the train is moving fastly, a train is coming faster along with the horn. So when it is approaching towards to you, the frequencies keep on varies. And same way when it will go away from you also, again the frequency is varies. So that is only we used to call it as Doppler effect. The pitch will keep on changes. So the speed of the moving object as compared to the speed of the sound in the surrounding medium is very important. That is only we used to call it as basically Doppler effect. So Doppler effect means two things you have to remember. One is speed of moving object. That is what you train or whatever it is, or you take it. And the speed of sound in surroundings. So the frequency when the object is approaching, what is that? When they are in a relative motion. So definitely there is no constant frequency or the pitch. So it will be keep on varies. That is only we used to call it as Doppler effect. So now coming to here, if you see the speed compared to the, like we can take the speed of the sound at, for example, if you take a sea level. So sea level means generally, so at sea level, so 15 degrees Celsius if you have been taken, so temperature is 15 degrees Celsius. Yesterday I have taught you one formula for calculating. Anybody can tell me? All of you? Temperature is this means we can calculate the formula. Yes, please. What is the speed at, suppose, at the 0 degree Celsius? Anybody? Yesterday I taught you. At 0 degree Celsius, what is the speed, guys?
331.
330?
1.
1 meter per second. Now they are saying 15 degrees Celsius. So what is the formula we can use it? Everybody. V at 15 degrees Celsius is equals to V naught into 1 plus T divided by 546. Do you all remember or not? Everybody. No, I would answer. Why? What is the use of teaching class? I don't. So if we substitute it at temperature now 15 degrees Celsius at a sea level, we will get a speed is approximately is equals to 340.5 meter per second, or we'll convert into kilometer per hour. We'll get about 1225 kilometer per hour. So this is the what? The speed of a sound at sea level when the temperature is 15. So but generally if you take that vehicles moving on a land, if you take, so the speed is even much less than this value. So they cannot even travel whatever the objects you can consider normally, like we'll take bullet trains, as I told yesterday. You take the fastest trains in the world, Japanese trains, Chinese trains, their speed is always less than this. So if you take the fastest train, I told, the fastest French train if have been taken, so that is what TGV. So fastest French TGV, the trains, which is recorded as about for 574.8 kilometer per hour. So it is less than sound. Am I right or wrong, everybody? Or we can say 160 meter per second. So this is what is the speed. Or else if you take the Japanese train, what is the name of the train? Japanese train. Yesterday I told you, all of you.
Maglev.
Maglev. So if you take the Maglev Japanese train, it is about to go with the speed of, okay, so about the same value. So even this all the things if have been taken, so the speed is comparatively less than the speed of sound in air. So now that is why we says, so here sonic boom means we all knows that the object speed must be greater than the speed of the sound in a given particular place. So that's why if you have taken like space jet, aircraft, so if you have taken the aircraft, space jet and all, so they will travel even much higher speeds. So while studying the aerodynamics, like you can take space jets, rockets, okay, this and all, you can see. So I basically the objects moving at higher speeds, it is very, very important that we have to consider the ratio of the speed of the moving object to the speed of the sound in the surrounding. So that is what is we used to call it as Mach number. So whenever you are designing like you can take aerodynamics like under anything, aeroplane, that is sonic planes, we can say it's like jet planes or this kind of war jets. So whatever it is, war planes. So everything we have to remember two things. One is speed of an object and another one is speed of a sound in a given fluid, means air. So that is the number. The ratio is only we used to call it as what we used to call everybody? That ratio only we used to call it as Mach number. So Mach number capital M with the honoring the scientist Australian physicist call it as Ernest Mach. So by the honor of his name we are choosing as a Mach number. Honor of an Australian physicist he is. So Mach number M is equals to is a ratio of what? Ratio of velocity of the object, open your mouth, velocity of the object divided by velocity of sound in the surrounding medium or the fluid. So that is only call it as Mach number. So if you have been taken, consider, let me take for example, Mach number may be equals to 0, or if you consider Mach number may be equals to 0, Mach number may be less than 1, Mach number is equals to 1 or Mach number is greater than 1. So let us see now. If I consider a stationary object, then what is the Mach number, everybody? Stationary object. Yes, please. The sound waves, everybody should answer, please. If I consider a stationary object, where Mach number become what? I want 0. So in this case, the sound waves produced would be concentric spheres. Okay. So in this case, if object is stationary, the sound waves produced is concentric circles. So please note it. Very, very important. Understand, everybody? I want response, people. All of you. So neatly circles you draw, complete circles. So when the object is at stationary, where object is stationary means what will happen, everybody? Yes, please. Stationary object means velocity becomes 0. So velocity becomes 0 means Mach number is 0. So in this case, object, the sound waves produced would be concentric spheres. That is what you have to remember. Next, Now, if the source of the sound moves with a velocity, let me take it as a Vs. Object is moving with a Vs, which is less or more, guys. Let me take, this is the velocity of the object, okay? And this is the velocity of the sound, okay? Let me take VO and Vs. Now, if the VO is less than Vs, Vs means what? I want answer from the people. Vs means what? Yes?
Velocity of sound.
Velocity of a sound. So velocity of a sound is greater than the velocity of the object. Means you'll get less than 1 or greater than 1. Numerator is smaller, denominator is bigger. So you'll get less than 1 or greater than 1 or equals to 1. Everybody. Yes? Real. Let it take denominator. Numerator is 1 and denominator is 2. Now you'll get less than 1 or equals to 1 or greater than 1.
Less than one.
Less than one. That's what. Hey, don't get out, everybody. Those who are not responding, please leave from the meeting. No issues. So when Mach number is less than 1, means object is moving with a less speed than the speed of sound in a given particular fluid. So in this case, if you notice it, if you see the spherical wave compressions would be shifted in the direction of motion of the source. So imagine now the source, the object is moving in this direction. So then entirely the concentric, the compressions is fully moved with the only the direction of the source. Do you all understand, everybody? Yes, please. Yeah. So by the time the source will be like this, you can see here all concentric circles, here only moving based upon the direction of that. That is what you have to understand. Make it quick. The what is that? Mach number is less than 1. The spherical waves compression, the spherical wave compressions would be shifted in the direction of motion of the source. That is what you have to write it. Make it. Would be shifted. The spherical wave compressions would be shifted in the direction of motion, of the source. Next, m is equals to 1. What do you mean by m is equals to 1? I want answer from the people. M is equals to 1 means what? Where Mach number? Yes, please. Mach number is 1. When it will become 1? Anybody? When is equals to 1? What do you mean by 1? Yes, the source at the speed of sound. So both will be traveling with the same speed. Means velocity of an object is equals to velocity of a sound in a given particular fluid. That is what. Means if you notice it, so if the source travel at the speed of sound, both are having the same speed, then we will get V naught divided by Vs, which is equals to, in place of V naught, Vs, so we will get 1. So that is what is the Mach number 1. So in this case, you see, the wave fronts would be bunched together at the object. So in this case, the sound would reach the observer along with the source. Means at a time source, at a time sound will reach the observer. So if you take the observer, he can like object also reach, object and sound reach at the same time. So that is what it is. So for example, imagine if a train is traveling, with the same speed, suppose like I will consider speed of a train is 340 meter per second and speed of sound also 340 meter per second. Now you are standing in the platform. Do you experience that train is already approached to the platform? Anybody? I want answer, please. Will you experience it? Train is approaching the platform?
Yes, sir.
Yes or no? No, you cannot identify
No, sir.
unless it will come to you. Unless it will reaches to you, you cannot see that train is approaching to you. Why? Train also comes at a time and sound also will reach us to you at a time. Understand, Mr. Pranav, Mukesh? So, what will generally now you see, you stand in a platform, what will happen? Sound will come first and then only train will come. Because why? Trains are generally travel lesser speed than the speed of sound. So, based upon the sound only, we'll understand that train is coming or train is approaching. Am I right, guys? Yes?
Yes, sir.
But in this
Yes,
case,
sir.
what will happen if the speed of the object and the speed of the sound both are same? So in this case, nobody can identify that object is approaching us unless it will come to us because both will go with the same speed. So that is what we used to say is m is equals to 1. So in this case, source that the sound which is coming to us at a time it will comes. So what will happen? Like sound cannot be heard unless the source reaches us. So that is very, very important. Unless the source reaches us, we cannot identify the object. Sound cannot be identified and object also cannot be identified unless we can. So in this case, how it will be? So like you can see is so this is the source of the sound object. So then every concentric circles will go from here only. Sanjay, understand Sanjay? Sam? So that is what? Prithvi? So that is how it will be there.
Right, sir.
So this
Yes,
is
sir.
m is equals to 1. This is m is less than 1. And this is m is, yes please. M is equals to 0. So Mach number m is equals to 0. This is m is equals to 1 and this is less than 1 and m is equals. So generally train is approaching a platform. We will get it this only. Am I right or wrong? Everybody? Yes or no? All of you? Yes, that is all. Now, we want another one that is only most important. That is only call it as sonic boom. So, if the source travels the speed greater than the speed of sound, means V naught, velocity of the object is greater than the source of a sound at a given medium. So in this case, Mach number is what? Greater than 1 because numerator is greater than denominator. So we'll get it greater than, yes please, greater than 1. Right or wrong? Everybody. So that is what. So the source proceeds the sound produced by it and the wave fronts lagging behind the source would form a cone. Okay. So what will happen in this case? For example, suppose your train is traveling faster than the speed of a sound. What will happen, guys? Anybody? Is it a good for us or bad for us? I want answer from the people. Suppose imagine you went to platform. You not notice the sound of a train, but the train came and passed. After that, you are hearing the speed of a sound. So is it good for us or bad for us?
No, sir.
No, sir.
So that's what. Okay. So we cannot experience it. Am I right or wrong? Everybody.
Yes, sir.
Yes. Yeah. So when the speed of a sound goes, so we cannot, like more than that, we cannot experience when the object comes, when the object leaves. So that's the reason. So this is how the sonic booms we used to make it. So that is only we used to call it as actually the sonic booms. So in this case, what will happen? Object run away, but behind the sound will be keep on like what? Still it is not reaching to us. So in this case, how it will be passes the sound waves, you can see. So imagine this is the source. So the sound waves will follow behind the object in such a way. So you can notice, okay? This is what? Sound. Sariyama? Ellame understand? Yes, please. So the sounds will
Yes, sir.
produce it like this. So the source precedes the sound produced by it. That is what. So what will happen? The wave fronts lagging behind the source. So source will run away, sound is coming backside. So they will form a cone actually. So in this case, Mach number is greater than 1. They will form a cone. Okay. So thus the source has passed the observer, wave fronts coming from opposite directions, and they would produce a intense thumping sound. So because of this overlappings and they are coming back, so this is the sound is very very high intensity. So this high intensity sound only we used to call it as, everybody, what does that call it as? Anybody? High intensity sound, high intensity, that is only we used to call it as, respond, we used to call it as sonic boom. So whenever you take sonic boom, means where is the Mach number? Mach number is greater than 1. So, sir, what is the example of this one? So, for example, what is the example of this one? Natural example. Yes, please. Thunder. So thunder is like that only. Thunder is an example of sonic boom, what we observe in nature. So in this case, a such sonic boom would cause that's what, rattling of doors, windows, and others. So have you noticed that rattling of windows, doors and all, that glass windows and all will breaks? Am I right? During lightning and thundering. Am I right, Sam? Yes, please.
Yes.
Yeah.
Yes, sir.
Like sound, windows and all will get a crack sound. Crack, 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 crack. That's what we used to say rattling. Rattling means making of series knocking sounds. So that is what meaning of rattling. Okay. So rattling means making a series of knocking sounds. So that thunder only makes the doors, windows and all rattling sounds because of this sonic boom. So sonic booms means high intensity sound where Mach number is greater than 1. So this is what you have to remember. So normal stationary object, if it will produces the sound, it is to be like concentric circles. If the moving object producing the sound, which is where speed of the object is less than speed of a sound, then it will be all the compressions located in the direction of object, and then where m is equals to 1 means Mach number, both sound and source is traveling at the same speed. Then where Mach number becomes 1, so in this case, both will reaches the observer at the same point. And then next, speed of object is greater than the speed of a sound. Mach number is greater than 1. So this is the case we'll consider. So what is the case? Sonic boom. The sounds are very, very highly intensive. So it is difficult to hear this. That is what is the sounds which we used to call it as sonic sounds. So natural example of sonic sound is formation of what? Everybody? Thunder.
Thunder.
So that is what. So object will leave first. The sound of the object will come back of it. So that is what we used to call it as sonic boom. So hope you all clear. Everybody, girls, boys, anybody having any doubt, please let me know. All of you understand? Yeah, is an example of. Yes, Gokul, you can take. So bullets will travel faster than the speed of a sound. That's why before we experience the sound, bullet will pass the targets. Okay, clear?
Yes, sir.
Yeah. So that's what. So this is what is about the Mach number and as well as sonic booms. Now I want to teach you the another new things, that is what for echo. So you can see that echo. So we all knows that reflecting sound from after striking the reflecting surfaces. That is what we used to say is echo. So echo means minimum two conditions should satisfy. What is the persistence of sound for humans? Everybody? Persistence of sound means persistence of sound. Humans. Anybody? I already taught you echoes minimum conditions here. What is the reflecting time minimum? That is only persistence time. Less than that, we cannot define which is echo, which is the source. Anybody? 0 point. What is the minimum condition for echo? Everybody. The required time period for reflection of sound is how much?
0
All of you?
point
0.1 second.
1 second.
Yeah, and the minimum distance is what? Between the resource and the reflector.
17.2 meters.
17.2.
That is. So, please remember persistence of hearing means d- the at least you can take like say in order to distinguish between the two sounds the time gap at least 0.1 second. So if you want to define this is one source and this is another source, like at least if you need to define the two sounds the minimum time gap must be 0.1 second. That is only ways to call it as persistence of hearing. So please remember that. So persistence of hearing for humans is 0.1 second. And if you have been taken the minimum distance which is required to calculate echo, what is the formula we all knows? Veloc echo formula. Everybody? Echo formula V is equals to 2S T. From that S is equals to V into T by 2. So of course we have studied this and all. So now you can see if you want to find determination of velocity of a sound using an echo, okay? So consider how to find it and there is a formula also. So let us take that and that is only the last thing which I want to say. So keep adding everybody. Determination of velocity of sound using an echo. So if you want to find the speed of a sound based upon the echo velocity, so let us consider there is a person P who is standing at, okay, consider a person standing at P in front of a hill or a big wall. That is what I will take it as a reflector. Hill or a wall, which we used to consider as a what? All of you? Yes, please. Reflector. Understand everybody? So the wall, it is if you consider. So let me take a time T1 be the time taken to hear an echo. So what is the time taken to hear the echo? Everybody? Time taken to hear echo. How much guys? Is
0.1 second.
let that is minimum time. I'm saying I'm considering here T1. Understand now? Yes, please. Now, when the person is here, if you all notice it, then it is taking a T1 time to hear the echo. Means from the source to going and coming back. Now, the person moves towards the reflector by a distance yes. So what is the distance traveled by a person? Yes. And he stand a position at Q and again produces a sound. So now the echo can be heard after T2 seconds. Do you all understand it? When he is at P1, when he is at P position, after how much time he can hear the echo? Everybody? Yes, please. After how much time? When the person is at P position, what is the time we consider to hear the echo? T1. Now, when the person displaces S distance, means he is moving towards to the hill. Now he reaches to the new position. Before the person is here. Now the person is here and he produce the sound. So now you tell me, what is the time taken to hear the echo? Is it the both T1 same or it is a different? Different only. Am I right or wrong? Time taken. Time taken to hear echo is T2 when a person is at what place? When a person at what place, guys? When a person viewpoint. Okay? So now we will make it all of you see and let me consider from the Q point, the distance present between the hill and the Q is, let me consider X. So what is the distance traveled by the person, everybody? What is the distance traveled by the person from the P to Q? Everyone, please speak, guys. Distance traveled by the person is how much, Amma? Yes.
Yes.
And after traveling Q distance, sorry, S distance, now the distance away from the hill to the person is S. So now V is equals to, what is the formula? Means again same, nothing else is there. So formula V is equals to, first case you can see. So in the first case, what will happen? S by T, total distance. Okay, total distance. So what is the total distance traveling? Anybody can tell me? Because it is going and coming correct. Going distance and coming distance. So 2 times. So total distance is equals to 2 times divided by time is T1. What is the distance? S plus X. Will you all agree with me? Everybody? When a person is at P. Yes, please respond, guys. When a person is in P position, velocity V is equals to 2 into S plus X by T1. Will you all agree with me? Now, when a person is at Q, can you tell me what is the velocity? When a person is at Q, only it is traveling X distance. Then what is the velocity? Speak, Ra. What is the velocity? 2x by T2. Okay, wa? Yes, please.
Yes, sir.
Now, from first equation you all see, I will write 2 into S plus X divided by T1, which is equals to V. Okay, or else I will consider, yeah, velocity only. Now I will consider 2 into S plus X. This T1 will come this side, which will become V into T1. Any problem for anybody? I want answer, please. Is it okay, everyone?
Yes, sir.
That's what. Then from that I will write 2s plus 2x is equals to Vt1. Any doubt, guys?
No,
Yes?
sir.
No. So now from the second equation, let me take this is second equation and this is the first equation. Okay. So now from this I will say 2x is equals to Vt2. Is it right or wrong, everybody? V2 will come this side, Vt2. Yes or no? Please respond.
Yes, sir.
So in place
Yes,
of 2x, what I can write, Amma? In place of 2, what I can write?
Me too.
T2.
Vt2. That's all. So in place of 2x, I'll write Vt2. So 2s plus Vt2 is equals to Vt1. Okay, wa? Now, Vt2 will come this side minus. So 2s is equals to Vt1 minus Vt2. So now, I will write it, V is a common, T1 minus T2 is equals to 2s. So definitely in this case, T1 is greater than T2 or T2 is greater than T1. T1 is greater than T2. Why? Initially, it is more distance. More distance means more time it will take. Yes or no, guys?
Yes, sir.
Yes. So what is the
Yes,
formula? V is equals to 2s divided by T1 minus T2. So that is only the formula. Okay, wa? Everyone understand?
Yes, sir.
This is the calculating velocity of a sound in the case of echoes. So echoes, if you want to find the velocity in echoes, this is what is the formula which you have to remember. So V is equals to 2 into S divided by T1 minus T2, initial time minus final time. Clear, everybody? For example, object will move away from that. By that time, what will happen? For example, the object moves S distance away from that and he obtain the new position. So can you tell me what is the formula in this case? V is equals to, yes, please, 2s divided by the time which is greater. Initial time is T1. Now final time is T2. So which is greater? T2 is greater than T1. Am I right or wrong? Do you all understand? Yes, please.
yes, yes.
In this case, he is moving towards to the hill, so that T1 is greater than T2. If he goes away from the hill, then T2 is greater than T1. Is it right or wrong, guys? Everybody?
Yes, sir.
Yes. So this is how to calculate this determination of velocity of a sound using an echo mathematically. If you want to prove, this is the formula. So generally now you see T1 minus T2. Can I take it as a change in time period? A difference between, that is what delta T. Is it okay, guys? Yes or no? That is only the echo formula generally. What is the echo formula? 2s by T. Same formula, correct? All of you understand? Yes,
Yes.
please. That's all. Okay. So if the object displaces, then this is the formula. 2s divided by T1 minus T2 or T2 minus T1. So based upon that, if towards to the reflector, T1 minus T2. If away from the reflector, going far away from the reflector, T2 minus T1. So that's all it is. So till here, anybody having any doubt, you can ask me. So this is all. Already you studied more than required. So make it quick, everyone. Anything doubt, you can ask me. Or else afternoon come with the physics books fully. So today we have to revise all the chapters, and then next week chemistry, that's all. Then exams will come. So please make sure you have to complete it, and you have to revise all the formulas and come by today afternoon.